Hello, I'm Chris, and this is AI Kilobytes, a show where we take complex works and break them down into easily digestible summaries. If you have not listened to the previous video in this playlist, I strongly suggest you go back, finish it first. Without further ado, today we will be dissecting chapters 3 and 4 of Daniel Kahneman's influential work, Thinking Fast and Slow. Chapter 3, The Lazy Controller. This chapter elaborates on the characteristics and limitations of System 2, particularly focusing on its laziness and relationship with effort and self-control. System 2's defining feature is that its operations are effortful, requiring attention and mental energy. These operations are disrupted when attention is drawn away. System 2 operates according to a law of least effort, being reluctant to invest more effort than strictly necessary. If there are multiple ways to achieve a goal, people tend to gravitate to the least demanding course of action. Engaging System 2 requires effort, which is associated with physiological changes such as pupil dilation. The amount of pupil dilation is a sensitive indicator of the level of mental effort exerted. Mental life, particularly that guided by System 2, can be described metaphorically as operating at the pace of a comfortable walk, sometimes interrupted by jogging or rare sprints. Difficult tasks, such as mental multiplications or the add 3 task, are near the limit of what most people can do and require significant effort. A crucial capability of System 2 is the adoption of task sets, which allows it to program memory to obey instructions that override habitual responses. Maintaining these task sets requires continuous exertion of effort. System 2 is also responsible for self-control and monitoring one's own behavior. Controlling thoughts and behaviors requires attention and effort. Self-control and cognitive effort draw on a shared pool of mental energy. When System 2 is busy or depleted by demanding cognitive tasks, lack of sleep, or alcohol, its ability to monitor and control the impulses of System 1 is weakened. This leads to System 1 having more influence on behavior, making people more likely to yield to temptation, make selfish choices, use sexist language, and make superficial judgments. The experience of ego depletion refers to a loss of motivation after exerting self-control in one task, making one reluctant to exert effort in another. Studies suggest this may be related to glucose levels in the brain. Depletion effects have been observed in areas like judicial decisions, where tired and hungry judges tend to fall back on easier default positions. The laziness of System 2 contributes to judgment errors, as it often endorses the initial intuitive answer provided by System 1 without investing the effort needed to check or correct it. The bat and ball problem is presented as a prime example where the intuitive but incorrect answer comes readily to mind, and a lazy System 2 accepts it without performing the simple check required. People who avoid this intellectual sloth are described as engaged and are more alert and skeptical of their intuitions. There's a distinction between intelligence, related to the algorithmic capacity of System 2, and rationality, related to the willingness to engage System 2 and question System 1's suggestions. Tests like the cognitive reflection test are seen as better indicators of rationality and susceptibility to cognitive biases than traditional intelligence measures. Longitudinal studies have linked the ability to delay gratification in childhood, an aspect of self-control, to higher intelligence scores later in life. Chapter 4. The Associative Machine. This chapter describes the workings of System 1, the fast-thinking system, primarily as an associative machine. System 1 operates automatically and quickly, generating impressions, feelings, and inclinations with little or no effort. When endorsed by System 2, these can become beliefs, attitudes, and intentions. The core mechanism of System 1 is the association of ideas. Ideas are viewed as nodes in a vast network, associative memory, linked by various types of connections, such as cause and effect, properties, and categories. The spreading of activation through this associative network is automatic and effortless. This process creates a coherent pattern of activated ideas that represents the structure of the world. Priming is a key phenomenon illustrating the power of the associative machine. Exposure to a word or stimulus can activate associated ideas, which in turn influence subsequent thoughts, actions, and emotions, often without conscious awareness. Examples include walking slower after being primed with words related to old age, or increased honesty box contributions when eyes are pictured. Priming phenomena arise in System 1, below conscious access. System 1 continuously monitors the environment and internal state, making basic assessments automatically and effortlessly. These include detecting distance, recognizing objects, understanding simple sentences, and identifying social cues. System 1 maintains a model of the world and distinguishes the surprising from the normal. An event that violates its expectations activates System 2 and leads to surprise and directed attention. System 1 automatically infers and invents causes and intentions to make sense of events and understand stories. This causal thinking is a core aspect of how System 1 processes information. System 1 is biased to believe and confirm. It engages in a confirmation bias, seeking information compatible with existing beliefs. System 1 neglects ambiguity and suppresses doubt. It jumps to a coherent interpretation of ambiguous stimuli based on context. The halo effect is an example of this, where initial impressions bias the interpretation of subsequent information, leading to exaggerated consistency. A key feature of System 1's operation is WYSIT. What you see is all there is. System 1 excels at constructing a coherent story from the information available, regardless of the quantity or quality of that information. This leads System 1 to jump to conclusions on limited evidence. System 1 can translate values across dimensions, allowing for intensity matching. This capability is used in answering questions that require mapping one scale, example, precociousness in reading, to another, example, GPA. System 1 engages in a mental shotgun approach, automatically triggering basic assessments and computations beyond what is specifically required by the task. This process can lead to interference when irrelevant computations conflict with the task at hand. So, there you have the dynamic duo in your head. The fast, intuitive, and sometimes error-prone System 1, working in tandem with the slow, deliberate, and often lazy System 2. They're constantly interacting, shaping every thought, judgment, and decision you make. Understanding this internal setup isn't just cool psychology, it's incredibly relevant as we develop and interact with artificial intelligence. Are we building AIs that mostly mimic our quick, pattern-matching System 1 with all its potential for bias and overconfidence? Or can we design AI that truly combines the best of both? The brilliance of System 1 with the rigorous, rational checking of an engaged System 2, but hopefully without the laziness. What are your thoughts on this? Which system do you find yourself relying on more often? And do you think AI can ever truly replicate that deeper System 2 style reasoning effectively? Drop your ideas in the comments below. If you liked this video, please give it a like and subscribe, as that really helps us out. Also, if you have any suggestions or critiques, we greatly appreciate any and all feedback. This has been Chris with AI Bytes. I hope to see you in our next AI Kilobytes video discussing thinking fast and slow. Until then, keep striving for greatness. Goodbye.